So now we're moving on to the third and final video of this section. That's revision and factorization. I realized the first two videos were quite long, so I'm going to try and go through this pretty quickly, and we can answer any and all questions that you guys have in class. So let's just get started on some problems. But before we do this, I just wanted to say real quick that these problems that we're going to do in this video are going to be following a formula. So it's going to be being able to identify something that's going on, and then once we identify that, we can use a formula then to factor. All right, so the first one that we're going to go through is going to be the difference of two squares. So remember, the first thing that you do, the very first thing we did in the very first video of this section, whenever we're factoring, regardless of what it looks like, we always have to look for a GCF first, right? That is the most important thing. You always need to look and see, do I have a GCF? No matter what type of factoring problem we're doing, that's first and foremost. All right, but then if you see that you have a binomial, and a binomial means that we have two terms, all right? So here we have two terms, 1 and 2. They're being separated by this minus sign. If you have two terms, the next thing you want to look for, because if you have two terms and this is a minus sign, then this is a very, very simple problem, or it could be a very simple problem for us to factor. All right, first we look for GCF. Well, it's just a squared and b squared. There's no GCF. Then we look and see, can I take the square root of each of these two numbers? Well, the square root of a squared is a. The square root of b squared is b. And if you can take the square root of both those numbers, and it's a binomial, meaning two terms, and then there is the subtraction sign. So the key thing is this has to be minus. All right, this has to be minus. It can't be plus. It has to be minus. Then that means our factored form is the addition of our two square roots and the subtraction of our two square roots. And whatever number followed that minus sign, in this case it was b squared, so the square root of b squared was b, that is a number that has to follow the positive and the negative sign. All right? So let's go ahead and do some of these. So this very first one, we look for a GCF. Well, there's a y squared, there's no y, so I know I can't factor out a y. A 4 and 9 have no common factor, so I know there's nothing I can factor out. Then I look and say, oh, well, I have two terms. I have a 4 and I have a 9y squared. And then the key thing here is it's a subtraction, so it's a difference. So then I ask myself, well, hopefully, cross our fingers, that these are perfect squares, meaning that I can take the square root of them. Well, the square root of 4 is 2. And the square root of 9y squared, well, the square root of 9 is 3. The square root of y squared is y. So since they are perfect squares, this means it is a difference or subtraction of two squares. And then our factored form will be adding the two squares together, so 2y plus 2 plus 3y. And then whichever one follows that minus sign, in this case it's 3y, we need to then do 2 minus the 3y. So the one following the minus needs to be plus and minus. All right, that is our final answer. So let's move on to this next one. Well, here we see that there are two terms, and each of these have an a. So the first thing I need to do before anything is I need to factor out that a. Because 9 and 16 don't have any common factors, so there's no number I can factor out. So when I factor out this a, I'm left with 9, and then a cubed divided by a, so that gives me minus 16a squared. All right, so remember, the very first thing that we always had to look for is this GCF. Then we look and say, all right, I still only have two terms. I have this 9 and a 16a. And then I look and say, oh, great, it is subtraction. So maybe this is a difference of two squares. So then I'm crossing my fingers and hoping. So I see, can I take the square root? Well, the square root of 9 is 3, so far it's working. The square root of 16 is 4, and the square root of a squared is a. So yes, I can take the square root of each, and it's a subtraction. So now that means that it will be the addition of these two squares, the square root, so 3 plus 4a, and then whichever one was following the minus sign, so that was this 4a, needs to be subtracted as well, so it's 3 minus 4a. And then we can't forget that original GCF that we took out, so that needs to go in front. So this completely factored is a times 3 plus 4a times 3 minus 4a. All right, so sometimes you will have to take your GCF out first before you can factor anything. There's one more type of problem that we want to go through, and then that is it for this video. All right, the next one that we're going to go through is perfect squares factorization, or the factorizing of perfect squares, or perfect trinomial squared is what it usually is referred to as. And trinomial means three terms, and here we have 1, 2, 3, 1, 2, 3. All right, so remember, the very first thing that we always look for is a GCF. Now, these two ways that I'm going to show you factoring here, you can just use the X method if you really want to. You do not have to use this way. It's just this way could be a little bit easier and quicker at times. But once we see that we have three terms, first thing that we always look for is GCF. right? There is no GCF for this one. It's 4, 4, 1. It has shared no common factors. X squared x. This does not have an x. There's nothing we can do. So the next thing that you see is if you notice that this first term is a perfect square. So 4 I know is a perfect square. X squared I know is a perfect square. So if that happens, what you should look and see is, does that third term, is that a perfect square? And 1 is, because 1 times 1 is 1. So if they are perfect squares, you then take the square root of each of these. Right? So square root of 4 is 2, square root of x squared is x, the square root of 1 is 1. After you do that, you then will multiply these two numbers together, and that gives me 2x, and then you need to double it. So 2 times 2x is 4x. If that matches this middle term, regardless of the sign, don't disregard the sign. If it matches that middle term, then our final answer is we take those two square roots, this 2x and this 1, we square it, and whatever sign was our middle term, in this case it was a positive, that is the sign that goes here. So it's +1. All right? I will show you in class why this works and why we have to double this here. I'll show you that in class. But those are the steps you have to do. So for this first one over here, remember the first thing we do is we look for a GCF. Well, here, all of these numbers, 8, 24, and 18, I know that they're all even, so I know that I can at least factor out a 2, and that is the only factor that goes into it, because 8 doesn't go into 18, and 4 doesn't go into 18. So my GCF here is 2, so I need to factor that out first. And then I'll divide each of these by the 2, and now I'm left with 4x squared minus 12x plus 9. Then I see I have a trinomial, so I have 3 terms, and I notice the first one is a perfect square because 4 and x squared I know are perfect squares. I can take the square root of that, so that will be 2x, and I look and say, can I take the square root of this third number? And I can, that's 3. Then I multiply them two together. 2x times 3 gives me 6x, and then remember I have to double it, and 6x times 2 is 12x. And if that matches that middle term, disregard the sign, if it matches that middle term, then we know that we have a perfect trinomial squared, and we then will write our binomial. We take our two square roots, 2x and 3. We raise it to the second power, and whatever sign is in front of that middle term is the sign that we use, so it's 2x minus 3. And then the one thing we can't forget is we need to rewrite that GCF out front. All right, the one thing I didn't mention, and I forgot to say this, I should have said this first and foremost, if you're going to use this method, the one thing that has to happen is the first number needs to be positive. So this 4x squared, this first number has to be positive, and so does this last number. If either one of these, first or last, are negative, we can't use this. So this needs to be positive, and this needs to be positive. All right, that is it for this video. We can go over any questions that you guys have on this, and we'll do a couple questions on a board before you guys start doing any problems in class.